Have you ever flown a drone? I haven't, but I caught it when my friend flew it, and that was very scary. Anyway, my friend, whose name is not Adam, is operating his drone. It is moving in a straight line. What a beautiful drone, moving in a straight line. And there's a tree, and that's when we start the clock, right? We start, okay, that's a broccoli, but right, we start the timer once it passes the tree. And we're given its acceleration. So let's have a think. So is it decelerating or accelerating? So at time is 0, acceleration would be 6. But 1 second later, acceleration would be -6. So its acceleration is changing. Alright, and 2 seconds after it passed the tree, it's got a certain velocity, and we're asked how far, so that's a distance, was the drone from the tree when it was traveling this speed. Cool. So we're given acceleration, we're given some information about its velocity, and we're asked to find a distance. So this is a very typical kinematics problem. So if you take physics, you can actually solve this using your kinematics equations. However, in calculus, we do need to show the calculus method. Just a reminder, the relationship between distance, speed, and acceleration. The rate of change of distance is speed. The rate of change of speed is acceleration. And conversely, if we take the antiderivatives of acceleration, we will get our speed function. If we take the antiderivative of speed, we will get our distance function. And since we're looking for a distance, we're ultimately going to want to know the distance equation. We are given acceleration, so to get to the distance equation, we're going to need to integrate twice. Right, once to get the speed equation, once more to get the distance equation. Alright, so we know where we're heading. So we're starting off with acceleration, 6 minus 12t. The speed equation is the antiderivative of acceleration. So the antiderivative of 6 is 6t. The antiderivative of minus 12t is minus 12t, but we raise the power by 1 to become squared, and we divide by that new power, 2. And I'll just simplify that in one step. So 12 divided by 2 gives 6. Alright, have we taken the antiderivative of acceleration? No, plus c. Right, a reminder, whenever we integrate, we add an unknown integration constant, because this could be, for example, plus 5, and the derivative of 5 equals 0. It could also be plus 100, but the derivative of 100 also equals 0. So we don't know. So that's why we have plus c. So let's solve for c. So to solve for c, we need to know a time and a speed. Because if we do, we can substitute those values in and then solve for c. So let's reread the question. Oh, look at that. 2 seconds after it passed the tree, so time equals 2, its speed or velocity is 20 meters per second. So there we have a time speed point. So substituting that in, so 20 goes in for speed and 2 goes in for t, so that we can solve for c. So 6 times 2 is 12, minus 2 squared is 4, times 6 is 24. 12 minus 24 is minus 12, add 12 to both sides, c equals 32. So therefore, our speed equation is exactly as we had it before, So 6t minus 6t squared plus c, where c we worked out is 32. So we found the velocity equation, which actually is the achieved part of this question. Alright, so we've got velocity now, making progress. We need to anti-differentiate again to find the distance equation. So let's do that. You'll often see distance written with an S, which in physics represents displacement, but in this problem, since it's a straight line, you can use D or S. So the distance is the antiderivative of the speed, so 6t becomes 6t squared divided by the new power 2 minus 6t cubed divided by the new power of 3 plus 32t. Yep, and plus c. So just in one step I would simplify that. So 6 over 2 is 3 and 6 over 3 is 2. Cool. I do encourage you to write all your steps just so you don't make any silly mistakes, but I have the benefit of a digital screen so I can just rub it out. Alright, have we found the distance equation? No. Alright, we need to find c. So again, this time we need a certain time and a distance. So let's reread the question. Get that broccoli out the way. So it's moving in a straight line, t seconds after passing a tree. Alright, I don't see any clear distance time combination. So often in kinematics problems, when it says like this, t seconds after passing a tree, means we start the stopwatch right when it passes the tree. So that's when we start the timer. That is also where we start measuring distance from. So in this case, it's implied that when time is 0, the distance the drone is from the tree is also 0, right, as it passes the tree. So we could write that. So when time is 0, the distance is also 0. And again, that is often implied in these types of questions, but do read the question thoroughly, because sometimes the starting distance isn't 0, but then they would have more information on that. But what that means for us is when distance is 0, time is 0, which, as you can see, since all of the terms other than c go to 0, c equals 0. Therefore, our distance equation is exactly what we had, except c is 0. So plus 0, or just don't need to write that. Alright. So getting that far is actually merit. And the reason why that's a merit skill as opposed to achieved is because we had to make that assumption there, right? That was implied. It was hidden in the question. Alright, but this is an excellence question. So let's see what else we need to do. We're looking for a distance, remember? When its velocity was 20. So we worked out the distance equation, but to find a distance, we need to input a time. Okay, but the question is said when velocity is 20. So, velocity is 20 at what time? So we can work out the time to then work out the distance. And of course, we have that velocity equation from the achieved part. So the 6t minus 6t squared plus 32. So finding time for v of t equals 20. So substituting in 20 in for v of t equals 6t minus 6t squared plus 32. And then solving for t. So subtracting 32 from both sides, or rather, no, we'll subtract 20 from both sides. So 6t minus 6t squared plus 12 equals 0. I'll divide everything by 6. So t minus t squared plus 2 equals 0. Just move over here. I will write the t squared term first. What else? Divide everything by -1. The reason I did that is so that the coefficient of t squared is +1, so that we can then factorize. What would that be? Two numbers that multiply to -2 and add to -1. So -2 and +1. So t would equal 2 or t would equal -1. Now, does it make sense if we have negative time? What that means is if we went back in time, too far, before the drone passed the tree, it would be traveling at 20 meters per second. However, we're only interested in after it's passed the tree. So, when time is 2 seconds. And why did we do all that hard work? Well, that time is when the drone is moving at 20 meters per second. Which we can now use to put into our distance equation to calculate the distance it traveled. Running out of room though. So our final line is the distance when time is 2. So again, using our distance equation, 3 times 2 squared minus 2 times 2 cubed plus 32 times 2. What's that? 4, 12, 12 minus 16 minus 4 plus 64 equals 60 meters. Oh, finally. So, let's recap that question. So, good old Adam, flying a drone. We were given the acceleration equation, which we then anti-differentiated once to get the speed equation, making sure to solve for c. We anti-differentiated a second time to get the distance equation, again solving for c. However, it was implied that distance was 0 at time equals 0. Right, so that was a bit sneaky. We then realized, okay, we're looking for the distance, but we're only given speed. So we use that speed to find the time, so that we could use the time in our distance equation to get 60 meters. And that was the excellence component. If you do level 2 physics, do try it out with your kinematics equations. It is a bit quicker because they encompass a lot of these steps that we did manually. All right, bye.